Welcome to Vedantu 11. I'm Sanaya, and today we'll master redox reactions, especially how to assign oxidation numbers. Oxidation numbers are like bookkeeping for electrons, key to reactions from rusting iron to batteries. Mastering these rules is your foundation for exams and deeper chemistry. Grab your notebook, let's dive in. Redox stands for reduction and oxidation, two processes that always occur together. In redox reactions, electrons move between species. Oxidation is losing electrons, oil, oxidation is loss, and reduction is gaining electrons, reduction is gain. One substance is oxidized, another is reduced. To track this, chemists use oxidation numbers. An oxidation number shows the hypothetical charge an atom would have if all its bonds were ionic. It helps us track electron movement. If the number increases, the atom is oxidized. If it decreases, it's reduced. Assigning these numbers follows clear rules. Let's learn them. Rule 1. Any atom in its elemental form has an oxidation number of 0. This includes single atoms, Na, Fe, and molecules like O2, H2, P4, or S8. It's the baseline. Rule 2. The oxidation number of a monoatomic ion equals its charge. Na plus is +1, Mg2 plus is +2, Cl is 1. Rule 3. Oxygen is usually 2 in compounds, like H2O, CO2, SO42. Exceptions. In peroxides, H2O2, oxygen is 1. In superoxides, KO2, it's 1/2. When bonded to fluorine, OF2, oxygen is +2. But most of the time, use 2. Remember the exceptions. Rule 4. Hydrogen is usually +1 when bonded to nonmetals, H2O, NH3, CH4. Exception. In metal hydrides, NaH, CH2, hydrogen is 1. Check what hydrogen's bonded to. That's the key. Rule 5. Fluorine is always 1 in compounds. No exceptions. It's the most electronegative element. Assign 1 every time. Chlorine, bromine, and iodine are usually 1, especially in halide salts like KCl or Mg-2. But when bonded to oxygen or fluorine, they can have positive oxidation numbers. For example, in ClO4, chlorine is +7. Default to 1 unless bonded to something more electronegative. Rule 7. The sum of oxidation numbers in a neutral compound is 0. For polyatomic ions, the sum equals the ion's charge. Use this rule to find unknown oxidation numbers. It's your algebraic tool. Group 1 metals, Na-K, are always +1. Group 2 metals, Mg-Ka, are always +2. Aluminum is almost always +3. These are fixed values. Use them as anchors. For other metals, always check the periodic table. Transition metals often have several oxidation states, like Fe2+, Fe3+, or Mn2+ to Mn7+. Assign values to other atoms, then solve for the transition metal. The sum rule is key. Always check the context. For organic molecules, use the bond method. Assign electrons to the more electronegative atom in each bond. Carbon's oxidation number rises with bonds to O, N, or halogens, and falls with bonds to H. Add up the changes for each carbon atom. Oxidation numbers define oxidation and reduction, help identify oxidizing and reducing agents, and are key for balancing redox reactions. The oxidation number method is powerful for complex equations. They also help compare agent strengths. These numbers are more than bookkeeping. They're essential tools. Use them to analyze reactions. Let's solve for manganese in KMnO4. Potassium is +1, oxygen is 2, X4 equals sign 8. And the compound is neutral. Set up, +1 plus X plus 8 equals sign 0. X7 equals sign 0, so X equals sign +7. Manganese is +7 in KMnO4. Systematic and simple. Redox reactions involve electron transfer, tracked by oxidation numbers. Remember the key rules and the sum rule for calculations. Practice is crucial. Solve problems to build speed and confidence. Mistakes help you learn. Keep practicing. That's it for oxidation numbers. With practice, these rules will feel natural. Like and subscribe for more chemistry videos. Drop your questions in the comments below. Happy learning. See you next time.